Now let's apply our graph concept, the slopes and everything, to a particular set of scenarios starting from when an object is at rest. So we're looking at not object, position time graph, velocity time graph, and acceleration time graph. So we'll do that for each case, when the object is in uniform motion, so on and so forth. So object at rest, there are two subcategories: object at origin, object not at origin. So same thing goes for everything. Now, first thing is, say this is your displacement time graph. If the object is at origin, right, basically, say you are home, we'll consider your home as origin. You're sitting home, you are here. So this is the case of object at origin. So this is example of object at origin. Now, if you happen to sit somewhere else, right over here, this, you are here. This is an example of object not at origin. I mean, I know it's kind of obvious, but still I'm writing. So what do you think the velocity time graph will be, or sorry, displacement time graph will be? It will be a flat line. But what about if the object is not at origin? Will it be the same? No. The object will be a bit far away, or a lot far away, doesn't matter. But it's at rest, indicating this. So let me explain this. So we have time 1, 2, so on and so forth, 10 minutes or seconds. At origin means what? After 1 second, the object is still at origin. 2, it's still at origin. 10, it's still at origin. Origin being your 0. And say this is 10 meters away. So the person is sitting around 10 meters away, outside the house somewhere. So even after 1 minute, he or she is sitting at that point only. So at minute 2, you guys are sitting over there itself, and at minute 10, you're still sitting over there. So this indicates that the object is stationary. Don't confuse this with object having some kind of velocity. No. The object is over there. If you think about it, a tree can be a best example. If someone does not remove a tree or a plant also, it will be at that position no matter what. Right? If your house is fixed, as in if you're staying there and you're not moving and the tree is not moving, so the displacement, the distance between your house and the tree will be fixed. And so displacement time graph will be flat. What about velocity time graph? So would it be something like this? So it will be flat and flat again. Would it be so? Nope. One is wrong. Which one is wrong? The top one is wrong. Why is this wrong? So if I take the time as say 1, 2 and so on and so forth till 10. So here the velocity indicates is 0. Obviously this is non-zero value. Say we can consider this as 10. So this is non-zero value. So velocity being non-zero value indicates what? Moving. So this is a case wherein the object is not at rest. So this is wrong. Can you guess how will acceleration time graph look like? Acceleration time graph, how does it look like? Obviously, the velocity is 0 means acceleration has to be 0. And so this is a scenario of no change in velocity. No change in velocity. Okay. So I think I covered. So it doesn't matter if the object is at rest or origin. I mean, rest at origin or not at origin, doesn't matter. For velocity and acceleration time, there is only one possibility. But for position time, you can have different possibilities. It's for all cases of rest. Okay, yeah.